Welcome to HTML5 webinar series from jpassion.com. Today's topic is SVG. All right, so let's move on to the presentation. So these are the topics that we are going to cover. So first, we are going to see what SVG is and why you want to use SVG, and then rest of the presentation we are going to cover most SVG the elements, and then we are going to cover how you can place SVGs in your web page, and then we are going to compare SVG against Canvas, and lastly we will take a look at some of the tools that you might want to use and shared image library out there. So some acknowledgements. So what is and why SVG? So SVG stands for Scalable Vector Graphics, and it's an XML language. It's a W3C standard XML language. So just like any other XML, it is a text. It's readable by machine, but also readable by humans. You can use JavaScript. In fact, this is the one big difference between SVG against Canvas. SVG elements are genuine DOM elements, so you can use JavaScript to take some actions against it. You can add some CSS styles, and you can associate some event handlers and things like that. So why SVG? So the files are generally much smaller than bitmaps, so it results in smaller and quicker download times. The graphics are constructed with a browser, reducing the server. So instead of the server creating the graphics, the server can send SVG file, and SVG file can be just constructed. SVG file can be just read by the browser, and then browser will display the graphics. And the end user can interact with and change the graphics without the need for complex and costly client-server communication. So whenever you have a need to display some graphics on the client, instead of actually creating that graphics on the server and send it to the client, you might in fact actually consider sending SVG file to the client, so the client can handle SVG graphic generation. The graphics can be scaled to fit different. Yeah, so this is again big difference between Canvas against the SVG. We'll actually talk about it, and we'll also see the demo of this. So graphics in SVG can be scaled without losing picture quality, while Canvas, because it's a pixel, when you are expanding it or zooming out, Canvas-based graphics will lose graphics quality. All right, so let's move on to see graphics elements. So in Canvas, the native, the shape that is supported by SVG is just rectangle, and everything else you have to construct it using the paths. In SVG, you have a bunch of ready-to-use shapes. So for example, text, rectangle, circle, ellipse, line, polyline, polygon, and image, and also it does have a path. So the way that you are going to specify SVG is that SVG tag, and then you are going to specify SVG graphics element. So in this case, I'm drawing a circle with these attributes. Okay. So this CX and CY is the XY coordinates of the center, and this is radius, and then you're going to fill it with color red. This is again the examples of basic shapes. This is rectangle, so things are pretty obvious, right? X and Y coordinates, height and width, and the fill, this is color. Stroke is black, stroke width is 2. And this is line, circle, ellipse, and image. This is text, so you can say text, and then again this is XY coordinates and font size, and then you are going to use red color to fill the text, meaning the actual text itself. Path. So path, you can actually use multiple notation like M, L, Q, C, A to indicate how the path is supposed to drawn. So M, X, Y means that move pen to coordinate X, Y. L, X, Y means draw linearly to coordinate X, Y. So this is the linear LXY. And so you know, in this case, you move here, and then you're going to actually use LXY to go to this point. QXY is quadratically drawn, so this is the example. And C is cubically, and A is elliptic. All right, so this is a path. So, you know, in this case, so let's take a look at this example first. So I want to move my pen to this location, the 150 here, and then I want to move the line from that point to here, so 250, and then I go back to here. So this 215, this L represent here, and this L represent this. This one, if you actually go to here and here and here, you know, basically automatically it's going to fill with black. Okay, so that's the default. All right, so let's do our first exercise. So here I provide a link, and the code is right here. So I can just click this one, and you can see what gets drawn. So this is a bunch of rectangles. Okay, so if you actually see the code, I'm going to just take a look at the first rectangle. So again, the coordinates and height, width, and fill, and stroke and black, and stroke is 2. Okay. I'm not sure which one it is, so let's actually try. Maybe I'm gonna just try fill with, how about green? Save. Yeah, so it looks like the first one, this one. Okay. So that's rectangle, and this is lines. So, you know, we have a bunch of lines. So 4, and these are considered lines as well. So let's take a look at the about this one. Okay, so here you can specify the line cap with a round. So that's what you are actually seeing right here. Okay, so you know, things are relatively straightforward. So we're gonna just move. Let's try. Okay, so this is what you see. And circles. So let's run this one. Circles. So here, let's take a look at just this one. Fill none, stroke is this color, stroke width is 30, stroke this the dash array. Oh, so this is the dash array. Okay, yeah. So if I change the stroke array with again yellow, let's see what happened. Yeah, so it changed yellow. All right, so that is a circle, and this is ellipse. Okay. And again, things are relatively straightforward. And images. So here, I get this image. And you're going to use image tag and specify the location of image with xlink, and then you specify height and width. Text. So here, if I click this one, this is what you see, and we are using text. So this is what you see, jpassion.com, and you can also specify the path, and then you can use the text path, meaning you are going to run this text along with this path. Okay, so that's what you see right here. Okay, the path. So this is what you have seen. So let's just run this one, and this is what you see. Again, the first path is this path, is this one, and this one is this. Okay. So let me just so if I want to change this one to stroke to green, and yeah, you can see it's changed to green. So this is the one that reflects this. Yeah, so this is something we talk about from the slide. The path with the fill rule set to defaults. So as a default, it will fill inside the shape with black. Okay. So if you click this one, oops. Oh, looks like yeah, I actually have a wrong path. So that is this one. So this is what you see. Okay. And if you take a look at the code, basically we construct with the various points. Okay. You can also have what is called the even odd fill rule, and this is what you're going to see. Yeah, this is what you're going to see, like this. So even odd is basically whenever there is actually some shape inside of others, it will have a different color. So that's basically what even odd fill rule is all about. So here, it actually use fill rule even odd. Okay, so that is some shape graphical elements from SVG. Now let's move on to transformation. So here we are talking about translate and rotate and scale. So this is we have seen that Canvas also has this transformation feature. So this is the translate. So suppose this is the graph that you have. So here what we have done is we have ellipse, this yellow ellipse, and then we have path. So here we created this path. This is basically this person's head shape is created using this the cubic, okay, the line, okay. And what we want to do is we want to translate, meaning we want to move this head shape to here, okay. So that's where we are going to use the translate 100 100 to the left and to the right, to the up. So that's why it's minus. Okay? So this is translate. And we are now rotate. So this is what we have now. We are going to rotate. The center of the rotate is the first parameter, and then the angle to rotate is the first parameter. In this case, we are going to rotate like a 90 degrees, and then this is the center. So you have to specify the center for rotation. And the scale, you're basically scaling these things to here. So basically, the X scale and Y scale. Okay. All right, so let's do exercise 2. So this is the before. So let's run this before. So this is what you see before any transformation. Okay. So now we are going to do translate transformation. So that's what you see, what you have seen in the slides. So let's actually run this one, and this guy actually move 100 pixel and 100 pixel left and to the right, to the upside. Okay, so that's what we just see in this one, and this one is rotate. Okay, and this one is scale. Oops, yeah, looks like my link is not right. So let me just go to here. And okay, so it's scaled. Okay, so that is scaling. So let's move on to grouping and reusing. So you can use G element to group things. So here we want to group these 4 graphic elements: rectangle, so 2 rectangles and ellipse, and the last rectangle. So this is ellipse, and we have 3 rectangles. And what we want to do is we want to perform the transformation for all these 4 elements as a group. So here you are going to transform, and we perform translate and rotate. And that's what we actually seeing here. So all these things are actually being transformed into transformed as a group. Okay, let's actually try that. So this is actually used to be like this, and then it's transformed. So if I want to transform to 100, let me just make sure, and it's moved right here, moved to the right, and rotate. Let's rotate to 150. Oops, not 50,000, 150, and it rotated 150 degrees. All right. And grouping with attribute inheritance. So you can actually have a group of these 4 elements, okay, and then you specify the attributes, and then you can have individual graphic element to inherit. So here, the first one will inherit black, this one inherit black, this one is also inherit black, but this one doesn't inherit black. Okay, so that's what's happening. So let's try this inheritance, and this is what you see. So suppose I do not want to inherit. Instead, inheriting, I want to actually, use red or something like that. So you can see it doesn't inherit from the group parent, but it's using its own. Okay. All right. Reusing is the same concept you see in other programming language. So basically what we have done is that we basically define an eclipse. You can have a lot more than here. And then we name it this with the G1, okay, with an ID, okay. And then we can use that eclipse just using use element, and then you specify the reference to that eclipse, and then you can actually have your own set of attributes. So in this case, we have this eclipse, and then we are performing some rotation. So that's what you actually see these 3 things. Okay, so let's try this. Okay, so again, if I want to have another one like this, and let's see what happens. So in this case, oh yeah, this is actually the same thing. That's why it doesn't show. So let's see. I'm gonna have maybe 90 degrees. See? Okay, and you can see it added one. Okay. All right, so that's reuse. Yeah, since I have already demonstrated, I'm gonna just move ahead. Gradients. Gradients, you can have linear gradient and radial gradient. So the way that you specify the linear gradient is that first of all you have to define your gradient, in this case linear gradient, okay, with in this case 2 stops, and then you give an ID, and then wherever you need to use that gradient, you're going to actually use fill, and then you specify the URL with the location, I mean the reference to that linear gradient. So this is what you see. Okay. Uh, Radial gradient works exactly the same. Okay, so basically instead of linear gradient, you're going to say radial gradient. So here, you can see radial gradient is being used. Again, we have just 2 steps. Opacity is basically using opacity values from 0 to 1. Okay, so we have 4 various shape, and they use a different opacity. All right, so let's do opacity exercise 4. So this is a linear gradient. So you can see its gradient from here. Okay, so if I want to add so it will say about 0.5 and then 1, and then this one is like green. Okay, so this is starting from white and it changed to green, and last one is black. Okay. All right, this is a gradient of the radial. It works exactly the same. Okay. So this is where things are coming from. Again, you can have multiple stops. All right, opacity. So here, yeah, so this is opacity. So, basically it's using opacity